all of these relations are something to be equivalent to the continuity of F. Sub jo hai equivalent. When I say, if you want to prove something continuous, you can choose any one of this description, just prove that, and that is going to be enough to prove that F is continuous. And then the last thing that I want to add is really equivalent to the epsilon delta definition. In other words, you have kind of a local version of continuity as well. For every epsilon positive, I find a delta positive such that if the difference between x and x naught is less than delta, this would imply that f of x naught is going to be less than epsilon. And then we saw that. What does it mean? It means that if x is in x minus x naught, x minus t, x naught minus delta, naught plus delta, this implies that f of x is in f of x naught minus epsilon and f of x naught plus epsilon. Subset here. Minus epsilon f of x naught plus epsilon. That's what essentially it says. Think about it. Okay, again, अगर आप x लेते हैं यहाँ से f of x कहाँ होगा? It is going to be the image of it. ऐसे ही. Otherwise, if you pick x from A, where is going to be f of x at? So it is going to be in image f of x. ऐसे ही. So if I pick an x from here, it's going to be inside the image of it. And then we are saying that that f of x, which is in the inside of image of this set, is also in this interval x. So this means that f of x naught minus epsilon plus f of x naught plus epsilon is subset of it. In other words, what I can say that for every neighborhood, I can find an interval such that if I look at the images of that neighborhood, it is the subset of what you call this interval actually. I mean, if you want to see it pictorially, it's nothing. If I say this is x naught, maybe this is function x actually, and you look at this neighborhood actually. ठीक है, छोटा सा neighborhood आपने ले लिया around x naught. Now for this neighborhood, which is x naught plus delta and x naught minus delta. For this neighborhood, I can find kind of an interval here, which is like an interval here, such that if you look at the outputs of these points, all of the outputs are going to fall within this interval. So in other words, this is what that essentially, the near points are mapped onto the near points. The nearness is preserved at the quantity. In other words, this is like a local definition. Local. You are doing it in real analysis. I'm not going into the details of it, but I just want to give you, a view so that you can also define continuity in a similar manner. Yeah. So what does it mean? It means that if you pick any points from x, so it's a local point-wise definition of continuity. ये point-wise definitions नहीं है इनमें से कोई भी. They are global. Open sets are mapped onto the open sets. But now you are saying that okay, you fix a point and you take an open set from the topology of x such that your point is inside this open set. In other words, I picked a point and I pick an open set that contains that point. Okay? So let's say this point is, this set is U. Now for this open set, I can find an open set here such that अगर मैं इस ओपन सेट्स के इमेजेस को देखता हूं तो वो सारे यहाँ इस ओपन सेट में fall. ठीक है. So the outputs of this tiny interval are maybe an open set fall inside this subject. By the way, this point also contains the image x. The x is mapped onto that one. So what I'm saying is that pick a point from x and pick an open set here actually, which is like a neighborhood of x. For this, I can find an open set in a topology of y such that, what is the key property in it? That if you look at the images of u, they all are going to fall inside. Okay? In other words, this is like really saying nearness. So you pick a point, and you pick something that is near that point actually. And then you map all those near points onto y, so they are going to be basically an open set. Okay, but this open set is obviously going to have this property that it is the collection of the near points around f of x. Okay, so the nearness is preserved. This is what that I want. So let's see that why this is true. Okay, let's see that all others are justified already. Okay, so I don't need to prove them. So I'm just going to prove that this continuity of f implies 1 implies 5. Equivalent statements वैसे कैसे prove करते हैं? So you try to make a chain actually. Yeah? So 1 implies 2, and 2 implies 4, and 4 implies 3, and 3 implies around 5, and something like that. And then 5 implies 1. You try to make chain actually. I don't need to make chain here because I have already justified that these 4 things are equivalent actually. The only thing that now I need to justify is that the 1 and 5 are equivalent to each other. So let's assume that 1 is true. In other words, f is continuous actually. And I want to show that this must be true. अब इसको prove करने के लिए I need to do what? I need to pick a point from x and I need to pick a neighborhood. ठीक है? And for that, I need to find an open set in y such that if I consider the images of it, it should be inside V. What should I do? All right. So let U कह रहा वो V कह रहा जो V कह रहा वो U कह रहा. That's the only difference actually. You need to read the book, but that's all right actually. Take it. Now, there is something. Let me just rewrite it. So what we are saying, you pick an x from x, okay? And you pick any open set U, okay, in Y obviously contain f of x. I can find a V on the topology of Y. I can find V in topology of x such that f of U is okay. I can find V from x such that x is in V and f of V is inside. Okay. slight difference between what I wrote previously and what I'm writing now. Okay, so here's the thing. I'm picking a point x from x. For this x, I know that there is going to be some output actually. Okay, let's say this point is f of x. And then I'm saying that pick a neighborhood of f of x. Okay, let's say this neighborhood is u. For this neighborhood, I can find a neighborhood of x, let's say call it v, such that if you apply f onto the v, all images are going to fall inside. Okay, so the images, all of these are going to fall inside. Okay, आप x लें और उसका आउटपुट लें, और फिर उस आउटपुट का नेबरहुड, take something that is close to f of x actually. Then इस neighborhood के लिए, and it makes sense actually. Why? Because epsilon delta में भी आप epsilon पहले choose कर, यानी अब ये कहते हैं that कि जो output जो है वो इस interval में होने चाहिए. इस interval के लिए, which is a collection of outputs, आप एक set of inputs ढूंढ सकते हैं, such that उस set of inputs के जो outputs हैं वो आपके neighborhood में लाएंगे. So that's what essentially we are trying to do there. For x, I am having an f of x, and I'm picking a neighborhood of f of x. For this neighborhood, I can find a neighborhood of x such that if I take the images of this neighborhood, all of the images are going to fall inside it. So this is maybe a more careful way of saying that. And it makes sense actually. अब जो है ना, otherwise जो मैंने लिखा था पहले उसमें, जो neighborhood v है ना, उसमें ढूंढने की मुश्किल होती है. Now it's really clear how to proceed with it. ठीक है. So I want to assume one function is continuous. In other words, it satisfies this or maybe any one of these conditions. It doesn't matter. ठीक है. And I want to prove this. तो अब इसके लिए मुझे क्या करना है? I'm going to say pick an x from x such that इसका output जो है वो कहाँ हो? Is inside y obviously. ठीक है? Or something obvious. Yeah, is inside v, where v is in. तो मैंने एक x pick किया, एक ऐसा x pick किया कि जिसका आउटपुट जो है वो एक v नहीं बल्कि u कहना चाहिए. ठीक है, because notation consistent है. ठीक है कि भाई इसका आउटपुट जो है is inside this. ठीक है. Now for this actually I need to find an open set in tau x. ठीक है, such that ये images जो है वो u में fall करें. अब मुझे बताएं, I think you should be able to crack it already that since f is continuous, so for every open set in y, I can find an open set in x actually. And what is going to be that open set? इसका inverse image ले लें, that's it. ठीक है. Now since f is continuous, so f inverse of u is open in x set. ठीक है, और इस f inverse of u का मैंने नाम रख दिया अभी. ठीक है, इस f inverse of u का मैंने नाम रख दिया अभी. Clearly, अगर f of x u में है, तो x must be inside v actually. X must be inside v. That's one thing. दूसरी चीज, अब सिर्फ साबित क्या करना है? Next, x is inside v, so we just need to show that f of v and f of v is a subset of u. Actually, the question is why. Now you can either use this generic set theoretic result actually, that कि अगर आपके पास inverse image है एक set का, ठीक है, उस इनवर्स इमेज का आप इमेज लेते हैं, इट इज अ सबसेट ऑफ ए। Either you can use this or you can, just run the definition actually. So you can say that let's say that I pick up y from f of v actually. Okay. So this implies that I can find an a inside v such that y is f of a. Agree? ऐसे ही if it is in the image set of f of v, इसका मतलब है कि इसके अंदर एक इनपुट एग्जिस्ट करता है जिसका ये आउटपुट है, ठीक है। So y is f of a. So if y is f of a and a is inside v, okay, then I can also say a, which is f inverse of y, is going to be in another set actually, and that is f inverse of u actually. चलिए इसको भी कह सकते हैं कि if y is an f of a must be in v, so this means that y is an f of a. अगर आप ये कहते हैं now, since a is in v which is f inverse of u, ठीक है, तो इसका क्या मतलब होगा? इसका मतलब ये होगा that f of a जो है is inside u actually. If a is in f inverse of u, so this means that f of a must be inside u. But this is what precisely the y is. F of a क्या है? Y. You pick the y from f of v, and you showed that the same y is in u, and v is u. ठीक है? So one side is justified. ठीक है? So if I quickly run through this, again पिक्चर बनाए, x के लिए f of x है, f of x का नेबरहुड लिया, उस नेबरहुड के लिए I can find the neighborhood here such that इस नेबरहुड के इमेजेस जो है इस नेबरहुड में फॉल करेंगे. ठीक है? यहाँ से हमने क्या किया? I picked an x. I know that f of x is going to be inside y. Let's say that u is an open set that contains f of x. ठीक है, अब मुझे पता है क्योंकि f कंटीन्यूअस है, इसका इनवर्स इमेज जो है ये ओपन होगा x में, एंड देन क्लेम ये है कि ये f of v जो है कंटेंस u है. ठीक है, so इसके लिए I picked a y from f of v which is same as that I can find an a in v such that y is f of a. ठीक है, but since a is in v which is f inverse of u, so therefore f of a must be inside u. But if f of a is inside u, that means that y is in u actually. So this means that you have this guy as a subset. ठीक है? How about other way around? How about other way around? Otherwise, let's prove that y 4 implies 1. So in other words, let's imagine that this is true. This is true. हर x के लिए, I can find an open set such that जो हर x के लिए अगर मैं एक ऐसा open set लेता हूँ जो f of x को contain करता है, तो इस open set के लिए मैं एक open set ढूंढ सकता हूँ v such that f of v जो है वो u के अंदर. So this is given to. So this is true in general. So I need to show what f is continuous. In order to show continuity, I can use this what you call criteria. So in order to do that, what do I need to do? I'm going to say that let v is open in R1. ठीक है? और claim ये है. Claim क्या है? Claim ये है कि इसका जो इनवर्स इमेज है, this is open in R1. Now how do you prove something is open?
Complement.
उसमें से एक एलिमेंट लें, उसका एक नेबरहुड ढूंढें, प्रूव कर दें कि उसको कंटेन करने वाला जो नेबरहुड है वो सबसेट है इसका. That's what you have to do. So let's begin X. So you see, once you have clear things in your head, I mean, you know what the steps I need to do. So let's say that I'm taking an X factor. Let's say that I'm taking an X from F inverse of B. ठीक है. By the way, अगर मैं V की जगह इसको U भी कह दूं तो कोई फर्क नहीं पड़ेगा. नाम है अल्लाह देता अल्लाह रखता जो रख दो कोई फर्क नहीं पड़ता. ठीक है, मगर इस नोटेशन फिर इसके साथ कंसिस्टेंट हो. ठीक है जी. Just follow me that inverse of U, where U is open and Y. So if X is in U, X F inverse of U. This means that F of X is inside U, where U is open in Y. Now here's the thing. Now think about this fourth statement. This is telling you, अगर आपके पास एक neighborhood हो जो F of X को contain करता है, then 4 tells you that I can find a neighborhood V जो tau X में होगा such that कि वो इसका neighborhood भी होगा and it's contained in. ठीक है? So by assumption, so by 4, I can find a V inside tau X which is open. Okay? Such that एक खास बात है कि X V में है एक चीज and F of V is inside F of V is inside U at. ठीक है? This is what it is. If F of V is inside you, I'm not getting into the detail, like this is something that you should prove now yourself. This means that V is inside F inverse of V. ये आपने खुद verify किया. ठीक है. You know, V is inside. But now V contains X and it's open in X sector. So what I did, I found a neighborhood of X that is contained in F inverse of U, and that fulfills the definition of F inverse of V. We open F inverse of U to be open. ठीक है मेरे, and I'm done. ये prove करना था that if you pick an open set, U from tau Y, its inverse image is open in X set. और उसको prove करने के लिए what I just did, उसमें से एक point लिया, उस point का neighborhood मुझे मिल गया, and that neighborhood is contained in F inverse of U, so therefore this F inverse of U is open.
So 5 से बन जा रहा है. So by 5.
कहाँ?
So by
अच्छा ठीक है. वो आपने correct कर लिया. I say all the things correctly but right. ठीक है जी. तो भाई ये 5 ऐसे समझ लें अब आपके पास criteria हैं. You have a lot of liberty. I mean, you want to prove something open. You want to prove some function continuous. You have very liberty now. Like you have 5 ways of proving it. Use any one of the way to prove basically that something is open. ठीक है? Are we happy with it? Let's move. So I want to move now something that builds on the same topic and then give you lots of examples of it. Achha, when you do linear algebra, groups नहीं पढ़ा होगा. What is a linear transformation? Linear transformation क्या होती है? So either fundamental meaning of linear transformation. क्या होती है linear transformation? पढ़ी है या नहीं पढ़ी? What's a linear transformation? So you have two vector spaces, V and W. Vector space is some object in which you can add things and multiply things. Actually, when you scale and multiply them. And then you have another vector space in which you can add things and scale and multiply. So a map is a linear transformation. Okay. If it preserves the structure. It preserves the structure. Structure को preserve करने का मतलब क्या है? V is a vector space in which I can add things and scale things. तो छोटा बड़ा कर सकता हूँ. Vectors को multiplying them into numbers, or I can add two vectors and get a third vector out of it. That's what essentially it is. ठीक है. दो operations. तो so T is a linear transformation. कि अगर आप दो vectors लें और उनको ऐड करें और फिर ट्रांसफॉर्म करें, या आप इनको पहले ट्रांसफॉर्म कर लें और फिर ऐड करें, कोई फर्क नहीं पड़ता. That's what essentially it is. So in other words, it preserves this addition, plays nicely with this addition. ठीक है? यानी आप ऐड करके ये करें, ये एक एक्शन है, this is some action actually, या फिर वो एक्ट अप्लाई करके और फिर ऐड करें. It doesn't make any difference. Yeah, and the same thing is that कि अगर आप एक वेक्टर लें, उसे स्केल करें और फिर ट्रांसफॉर्म करें, दिस इज सेम एज कि आप उसे पहले ट्रांसफॉर्म कर दें और फिर स्केल. This is what the linear transformation is actually. और अगर यही linear transformation एक बाइजेक्शन की हो, फिर क्या होगा? Then call it that's a isomorphism. By the way, इसको आप कहते हैं this is vector space homomorphism. This is algebraists like to call it this is vector space homomorphism. Morphism. पढ़ा? You might have encountered this love word like morphing actually. Morph का मतलब क्या है? Mimic कर सकते हैं. Metamorphism. Morphisms actually. And then you are saying that homomorphism. There is kind of a homogeneity in both vector spaces. So that's a vector space homomorphism. So the good thing about vector space homomorphism is that if you know that two spaces are homeomorphic, what does it mean? That whatever things that you are adding, subtracting, scaling here, ठीक है, उसी तरह की एक addition और scaling वगैरह, you can do the same thing here. So they both have roughly the same algebraic structure. The way you do algebra in this vector space, you can also do algebra in this vector space as well. यहाँ भी यही कर रहे थे. You are doing algebra, but where? In V. And here, यहाँ आप algebra कहाँ कर रहे हैं? This is telling you the way you do algebra in V is same as the way you do algebra in W. So they kind of mimic each other. ठीक है? They kind of mimic each other. Anyway, so we're gonna get into it. Not gonna get into that. Now you can have a similar notion in topology. When you get into the algebra, you will find all kind of homomorphisms in the structure. But that's what it is. आपके पास एक structure है, उसके अंदर यहाँ तो 2 operations हैं, अब 10 operations हैं. उस structure के homomorphism का क्या मतलब होगा? एक ऐसी map जो 10 के 10 operations को preserve करे, उनको respect करे. ठीक है? Anyway, so now you can have also the same thing here.